Okay, thank you everyone for joining tonight. Or it's tonight here in South Africa, and a few other places it's not night. But thanks for joining. Archie is going to be speaking about machine learning. I'm very excited about it. I did hear there's a few problems with the AWS meetup site, so people might be joining a bit later. And we are also doing something different. Usually we leave questions until the end, but you can unmute yourself or you can pop the question in the chat and then we'll answer it in the end. But you can unmute yourself at any point within the presentation and then you can just ask your question. There's also going to be a lucky draw at the end, and your entry to that is to fill in a quick 1 minute survey. We just like to collect some data around what you guys want and like what presentations we can present in the future. So just fill out that and then you can get $25 credits at the end. Actually, I'm gonna hand out a few more than 25, so maybe 3 25s. I have a few of those credits
Yeah, you're
and
sick. Those are lungs of me, she's
mute you quick. Okay, yeah, so I think that's it. Thank you, Archie. You can introduce yourself and start.
Right, thanks, Rian. I actually, like Rian and I actually have worked together a couple of years ago, and at that point I just started with this whole machine learning side of things, and I've actually had the privilege of seeing AWS grow in their ML services, and I must say, like, it's actually gotten to a point where a lot of the servers have gone way beyond my expectation. So I'm actually quite honored to be able to do this demo right now. Essentially, what I wanted to actually do, and I asked Rian earlier as well, is I wanted to create a bit of an interactive platform because I'm not really sure. It makes it difficult when you have virtual setup because you can't really see how people are engaging. So if at any point any of you have any questions, please feel free to stop me and then I can dive into it a bit more in detail. I did say I would go through a lot more services, but I'm pretty sure I'm not going to be able to go through as many services as I'd like to go through. But yeah, but you guys can always let me know by the surveys or let Rian know around what exactly you'd like to cover in the next couple of talks from here on. So my background is I am actually I actually have a background in electronics and electrical engineering, and then as a result of data, I came into this field of machine learning. So essentially what happened was I actually started looking at data and I started seeing that there's actually some very interesting things that we can do with data. And for me, it almost felt like if we don't look at our data, we're not going to be able to progress into the next phase of technology. And that's essentially how I got into the field of machine learning. And ever since then, it's been a love-hate relationship, but we've been going at it, and it's been great so far. I've had the privilege of working predominantly in the mining and the financial sector. I have dabbled into the healthcare space, but as a result of PII information, personally identifiable information, it's always difficult to get more experience in that space. So today what I'll be speaking about is I'll give a basic introductory view around what machine learning is, what AI is, and what you actually need to take into account when you want to take a machine learning model or a machine learning product into a production environment. It's not as easy as it sounds. It's not as simple as training a model and then boom, you have it already. There's a lot of factors that you need to encounter. There is the obvious software engineering principles that you need to still cater for, which is often forgotten. So what I'm hoping by the end of this, if there's anything that I could leave all of you with, is that you still have to cater for your software engineering best practices and your cloud engineering best practices when deploying models and when getting machine learning into the production space. So yeah, I'm going to begin. Cool. So just high level around what I'm going to be tackling today is just basically understanding what AI means in practice, understanding the complexity of maintaining AI in practice. And the reason why I'm honing on this in particular is because it's, like I mentioned earlier, it's not as easy as it sounds. It's not as easy as dropping a machine learning model into a production environment and letting things just happen. It requires a lot of tender loving care at this point. Then I'll be just going into some of the case studies. I unfortunately couldn't take an actual production load because data privacy. and I will get into trouble for that. So I'm just going to go over high-level concepts of what it is that I've actually deployed in the past, what learnings I've gained from that, and then go through a quick demo. But if at any point you want me to dive into a little bit more detail, please do let me know. So let's start with, what does AI mean in practice? Cool. So what is AI? Let's start off with that. I don't have a diagram. Usually what happens is we actually have a diagram that shows AI as being the top principle, and then we have machine learning, and we have deep learning, and we have reinforcement learning. But just to give you a high-level concept around what it is that artificial intelligence is it's exactly that, right? We're trying to take intelligence and we're trying to package it into a system. It sounds very absurd, because then what is a program? What is normal software then, right? The difference here is predominantly what we usually have with a system is we have a set of inputs. We have a code base, like some sort of function we actually will be tweaking the inputs with and then getting an output from there. But now, what we have now within the machine learning space is we've got a set of inputs, we've got a set of output data, and now we want to understand what the internal workings are. And that's essentially what we're doing. We're trying to understand what the code is, and we're trying to change the code as the input and the output changes over time. The benefit of this is scalability. So it's often a debate I have to have with people, because they say, why do we need machine learning? Why do we need AI? Why do we need anything of the sort, right? Why do we need to actually get into the space? So essentially, the reason why it's important to get into or understanding what machine learning is and to get into the space is because we don't know how fast our data is going to change. Our data, we're getting tens and thousands of data inputs on a daily basis. We have so many different outputs changing on a daily basis. It's almost impossible for human beings to just understand what these patterns are, to just understand what these formulas are. So that's essentially where machine learning comes into play, right? Because now we actually have patterns that can help us to understand what the difference is in data. So, any questions so far? Is everyone still with me? Okay, cool. Since there's questions, I want to carry on. So, along with this very complex concept, something that needs to still be catered for is, how can it go wrong? How can we potentially solve for it? And how can it go right? So let's start with the easy part, right? How can it go right? If it goes right, we could potentially have a Terminator on our hands. We could have a robot that could do all these things for us without us even having to program it from scratch. That's how it can go right. How it can go wrong is if it goes in the opposite direction and ends up doing its own thing. That's essentially the two differences. It's simple enough to understand. So how can we what can we do on our front to ensure that it doesn't go wrong? Because we don't want to create a system that we can't actually we can't actually build for in the long run, right? We don't want to put something out into the environment that we're not sure will actually turn out the way we want it to turn out. So how can we prevent that? This is where basic engineering that we hate, the software engineering practices, the engineering practices, the use of AI. This is where all of that stuff comes into play. Because without having those things instilled from the beginning, we won't really be able to build something that's sustainable and scalable in the long run. So that's high level what we're trying to build towards. We're trying to build towards a set of best practices. We're trying to build towards a set of ethical standards that we can follow, so that in the long run, when we are using machine learning and artificial intelligence concepts, we're using it in the right way. And we're not using it in a way that we're basically messing our lives in the long run. Any questions so far? Okay, cool. So I'm going to go to the next slide. Okay, this is just a meme because I like putting memes in our presentations. And it's actually true. It's actually very, very true. And something that I always stress when people come to me and tell me that, but AI is going to take over the world, and AI is going to do this, and AI is going to take over my job, is look at this meme. We have a very simple cat picture that has been identified as a dog, right? Like, this is a very basic concept. This is something that as human beings, we're like, this is ridiculous. Why is it being labeled in this way? And this speaks to how simple AI is. And it's not actually as scary as we think it is. It's actually, I mean, if you're to think about it, AI is something that's designed by human beings. And for those of us in the software space, we know human error is a real thing. Human error and human code is only as good as we write it. So it's not as scary as it seems. There is actually places within the industry where, yes, AI is being used, but it's not being used in a destructive sense. It can't be used in a destructive sense. It's only as good as a human being builds it out to be. Yes, we are getting to a point of maturity where there are very interesting things such as deep fakes, which is, actually recreating a person's face and actually getting people to, or getting these deep fakes to say things that other politicians or celebrities haven't really said themselves. Yes, that is a possibility, but once again, your model and your system is only as good as the data that is out there. And that's why it's important to have the way when you build out a system, make sure you do it in an ethical way. Make sure you do it with data security in mind. Make sure you do it with data privacy in mind, because without any of these things, we're not going to be able to build a sustainable solution. So that's my story. Any questions so far? Cool. And so what are some of the areas? I've spoken for a while now, and I've mentioned like the problems that we could potentially have, and I'm just going to go take it one step further into understanding what it takes to actually maintain a model. Now, it's going to sound very silly, but machine learning is literally a small little blip in the entire spectrum of a system. Okay, sorry about that. Okay, so basically what I said was machine learning and machine learning code is literally a small blip in the entire system. So if you can look at this diagram, we've got this white block is essentially your entire system, which entails automation, feature engineering, data verification, configuration, metadata management. So many of these million concepts, but when we're to talk about actual machine learning, it's one little small element. And how scary is that? Because if we're to think about the hype that AI and machine learning creates within the world, it's actually not that big. It's a small little concept. And if we want to actually get it right, we need to ensure that all these other elements are working just in harmony as well. If we don't have that working, then we've got no system. We've got no production grade machine learning model. We've got no production grade AI model. So something I'd like to just stress a little bit more is that as much as there is such a hype about AI and as much as there is such a hype about machine learning, don't forget your basics. Don't forget your basic software engineering concepts. Don't forget your basic system engineering concepts, because that is actually more important than the actual machine learning model. I know I sound like I'm contradicting myself, but that's the reality. That is the reality of having a machine learning model in production. We have everything else that needs to work first before we can actually get a machine learning model to work well in production. And in order for us to actually ensure that we can make a scalable solution, you need to ensure that your basics are in place. If that's not in place, there is no machine learning, there is no AI. So when building out a machine learning system, and it's all great, and I think AWS does a great job because they've actually got these services prepackaged and ready to utilize. But in order to actually take that to the next step, you need to ensure that everything else works. And that's why you need to still have your security, your best practice security in place. You still need to have your network in place. You still need to ensure that you have your CI/CD pipeline. Like, all those things still need to be in place. And if it's not catered for, you don't have a production grade system. Any other questions? Cool.
I believe there was one, but I think you just I think that you just answered it as well.
So, did I? Oh, great. Great. I can see into the future. So, so what I'm showing you here right now is that this is a typical technology stack of a machine learning model in production. And if we're to just look at it high level, do you see any kind of AI concepts? There's no deep learning models. There's nothing that is actually hype worthy in here. These are all basic things that are in place. And to be completely honest, this is the sort of system that a machine learning engineer works with, right? This is essentially, we still work with software engineering technology stacks. We still work with cloud engineering technology stacks. We still have to work with security. We still have to work with networking. And without using all these different tech stacks, we actually can't take a machine learning model into production. So this is just high level around how complex it is to actually get, let me not say complex, how it's very similar to get a machine learning model into production, just like a software engineering product. It's the same sort of concept that you still have to cater for. I actually think that there's an extra layer of complexity when it comes to the CI/CD pipeline of things, and the only reason is because when you actually have a software engineering product in an environment, you just have to let it out there, and it should over time it'll work itself out. Whereas with a machine learning model, you have to constantly keep monitoring it and ensuring that your model is still up to scratch. So that's the only difference. So the complexity in terms of the machine learning operations, but in terms of the concepts that you still have to consider, it's all very much similar to a software engineering process as well. Any questions? Okay, doesn't look like it. Cool. Now let's get into a typical machine learning lifecycle. I know it looks a bit weird, but essentially, if we're to start from top to bottom, how we go about doing this is we start off by identifying a business problem. Once again, very similar to a software engineering product as well, right? You start off by identifying a business problem. You have to, in this particular case, you would have to reframe it into a machine learning problem. The only difference is when you're reframing it into a machine learning problem, you need to identify what data set you need. You need to identify what sort of features you're looking out for. And you need to identify what sort of models you could potentially be utilizing in the first iteration. That's the constraints that you look for when you're trying to get a machine learning, when you're trying to reframe it into a machine learning problem. After that, we go through and I was speaking to Chris about this earlier, like we literally have to go through the same sort of data collection, integration, data cleaning and preparation. And it's going to sound weird, but 80% of my life lives in the data cleaning and preparation phase of things. It's so sad, but that's how it is, because literally your model is only as good as your data. It's garbage in, garbage out. So if you don't have good enough data, and if you don't have data that can actually help you to build out a good enough model, you don't have anything, right? So that's essentially why it's so important that your data collection and your data cleaning and preparation is looked after, and a significant portion of your project needs to be dedicated to that. Yes, there are many ways that it can go wrong. You might even get to a point where you've identified the wrong, I've done that before, where you've identified a wrong data source, and you're 100% sure that this data source is going to work to build this model, and you find that you were completely wrong. You would find that the data that has been collected is actually completely misguided from what you're trying to solve for. I actually had this problem when trying to build out a fraud detection model, so you can imagine how haywire that way. So that's why it's so important to ensure that when you are collecting data and when you are cleaning and preparing your data, you've made sure you've done your due diligence in identifying the sources, you've done your analysis around it. Don't trust people. Just make sure you do your due diligence on your side to ensure that you have the correct data sets and it makes sense. And that's 80% of your life gone. Then
I have a question. Yeah. Well, when I was doing my project, one of the things I found that gave me a better result was someone told me about adding clutter and adding, like you said, it's garbage in, garbage out, but sometimes you want to add garbage. Like, what kind of problems does that help with? Because that was the really non-intuitive bit for me.
Yeah. So what exactly were you trying to solve for in your particular instance?
It was a computer vision. So I was trying to identify different things from different images. And so they told me to add in pictures of airplanes and animals and things that had nothing to do with what I was looking for, which seemed weird.
Yeah. So this is the beauty about data, right? Because if you don't collect enough of a distributed data set, so if your data, let's say now you're trying to identify kitchen utensils, right? And you have out of 100 images, 80% or 80 of them are cups, and 20 of them are cutlery. You're always, because of that spread isn't even enough. What you find is that because 80% of your data set is cups, your model inferences are always going to be cups. Like it's similar to when you're training a baby. When you're training a baby to, I don't know, maybe start saying a couple of words, and if you constantly keep saying the same word, irrespective of what image or what object you put in front of the baby, they're automatically going to say what they're used to and what they're familiar with. And models are exactly the same. So the benefit in your particular instance, where you're basically trying to skew the bias. So you're trying to skew the bias and distribute your data set more to ensure that you have more accuracy. I know it's counterintuitive, but remember, your model is literally only as good as you train it. So if you train it with 80% of cups instead of only 20%, then that's what you're going to get most of the time. Does that answer your question?
Yeah, cool. Thank you.
Cool. So yeah, so then that's basically, once you've cleaned and prepared your data, then this part, this data visualization and analysis, right? You might think it's a small part of your entire process, but actually this is essentially where you start finding out. And this is actually, Chris, what you've just mentioned now with regards to understanding how well your data fits and whether you have an overfitting or underfitting of your model. This data visualization and analysis is essentially key for that. Because once you've prepared your data and once you've actually ensured you've collected data sets, you need to understand how evenly spread your data is to train your model. And if you don't really have that visual element, so I mean, if I'm to go back to this image, right? Not this image. Not this image. Let me get there. So if I'm to go back to this image, right, we find that the ML model, ML code is a small element of your entire distribution. That's essentially what you're trying to visualize. You're trying to visualize how is your data distributed in the grand spectrum. So if you don't have a way of visualizing how well your data has been spread over time, then you don't necessarily have a good view on how well your model will be predicting things. So that's why, like, as small of a part it is of your process, it's absolutely essential to have that visual and then analysis there, because this is essentially the point where you can understand whether this will lead to whether you need to augment your data or not. And that's essentially this part here. If you can see the feature augmentation, data augmentation, this happens quite logically. It happens directly after your data visualization and analysis. Right? Because once you've actually understood what your data represents and how well it's distributed, then you know that, okay, I've got 80% of my distribution is cups. I need to bring in more of the other utensils. That's when you know at that point. And then once you've figured that out, then you would need to bring in more data sets to ensure that you've got a more representative set. So yeah, then you would have your augmentation process happening here. And if by some miracle in your first iteration you've managed to get an accurate representation of your data sets, which never happens, which usually never happens, then you would go directly into your feature engineering aspect of things. Now, what feature engineering is once you've actually identified a well-distributed data set, now you need to understand what sort of features you're looking out for. Now, an example of that is, let's say you are trying to train a document understanding solution, right? So let's say you're trying to, it's a computer vision problem. You have a document, you're trying to identify, and let's say this document is an invoice. right? And you're trying to identify who the client is, you're trying to identify what the amount is on that particular invoice, you're trying to understand what the address is, and then you want to be able to make an inference from there in order to understand what sort of invoices are being populated, what sort of people are actually engaging the system, etc. So features are essentially those little points you're looking out for in your invoice. So it could be your invoice numbers, it can be, let's say, your addresses. In a completely different problem, let's say, for example, in the situation where you're trying to figure out what sort of kitchen utensils you have. You want to look at density of an image. You want to look at the color of the image. You want to look at the size of an image, right? So those are features. So once you've actually established what those features are, then that's your feature engineering done, right? It's actually it can be quite difficult depending on how complex your problem is. Complex problems, for example, the fraud detection system. Trying to like imagine you have millions of transactions coming at 10-second intervals, and now you have to try and identify features that could potentially tell you that this is a fraud detection problem. How on earth do you actually go about doing that, right? Like, how do you know that one feature is more important than the other feature? So in the data science realm, we've got this concept of exploratory data analysis, which is essentially where you try and retrofit different features to figure out which one actually makes more sense. It's a bit of a process, because if you have a complex problem, you want to be able to, you don't want to mess it up. You don't want to mess it up because it's definitely could be highly dangerous if you do mess it up. So yeah, that's essentially how you go about identifying which feature is actually important. And once you've identified what feature is actually important, okay, I'm here. Here. Sorry. Okay, so once you've actually identified your features and you know for a fact that these are some robust features that you need to be looking out for, then we have the cool part, which only takes 20% of your entire life cycle, which is actually model training and hyperparameter tuning. So all that is basically you kind of like thumbsuck a specific algorithm. Let's say, for example, you want to do an XGBoost just to kind of build out a predictive system. You say, okay, I'm going to use an XGBoost algorithm to ensure that I can actually predict what fraud detection model should be, right? And then you would actually go about training it on a smaller subset to see if your thumbsuck was actually correct. And that's what, okay, so once we have chosen our algorithm and once we've kind of figured out that we've actually got the most adequate algorithm for our system, then our next step is obviously understanding to see, based on a different data set, is this actually going to work, right? So essentially what we traditionally do is we divide our data set into three parts. We have a training set, we would have a pre-evaluation set, and a final evaluation set to understand what the accuracy of your model is. So in the model evaluation step, what we do is we look at that pre-evaluation data set, and we try and find any kind of like, we would actually do inferences on our model on that pre-evaluation data set, and then see how accurate it actually is. So you might be asking, like, how to actually measure accuracy. So essentially what happens is this pre-evaluation data set is already labeled, right? It's already labeled, and it already knows what is correct and what isn't correct. Are you still?
Yes.
Okay, still here, right?
Yes.
Okay, sweet. So once we're happy with our pre-evaluation data set, and let's say our accuracy is above 70-75%, then what we can say is, cool, we've got our business goals have been met, and then we go into the yes process. But if not, and this is why it takes so long to actually build a model, you have to go back and redo the entire process again. It's just from me talking about it, it took so long. So imagine when actually doing this in real life, how much longer it takes to build out a model. And to be completely honest, like this process actually takes quite long. It takes quite long to get a model that we're happy with. And depending on how much of a high profile model this is, still there? Yes. And depending on how much of a high profile model this is, you would need to ensure, so for example, there's some things that there is a completely non-negotiable, right? For example, let's say you have an aircraft and you need to start performing anomalies in your aircraft system. You're responsible for millions of passengers on the aircraft. You don't want to mess that up. You can't have an accuracy below 99% in that particular instance, right? Because if you don't pick up any kind of anomalies or anything that goes wrong in that system, then there's people's lives at hand. And there's people who like, that's a high risk profile. So in those particular instances, 99% is absolutely essential. Actually, 100% is absolutely essential, but we play around the 99 and the 100% range. And in a less serious situation, let's say, for example, you need to identify if a person is of a specific color, or you need to identify if an object is round or square. That's fine. Like, I mean, if something is tagged as round instead of square, it's not a train smash. So in that particular situation, it's fine. We can get away with it. Another scenario is, for example, let's say we're in the personalization world. And in the personalization world, you want to be able to target and market only specific things to a person. And that is probably like a medium risk situation, because at that point, what is at risk is if you target them with the wrong product. If you target a person with the wrong product, then that's your risk. It's not a life and death situation. So depending on how risky your actual product is, you would need to tweak your business goals are met by that accuracy rate. So let's follow happy path, right? Now we have a fantastic model out there. It's high accuracy. It does what it needs to do. So next step is model deployment. Now, this model deployment phase is exactly like a software engineering product. Literally, you would get it into a CI/CD pipeline, and so I call it CI/CD and CE. So essentially, CI/CD is continuous integration, continuous deployment, and continuous evaluation. So I've just added the CE component to it because the reason why we need to have that CE component is you constantly need to evaluate your model. Once your model has been dropped into a production environment, that is not the end of it. Actually, it's the beginning of it. It becomes the beginning of the process, because once your model is in production, then the next step is you have to constantly evaluate it to understand if you've got a drift in your model. So what do I mean by a drift? A drift is essentially when your model is constantly getting it wrong, right? So if your model is constantly getting it wrong, let's say, for example, you have a fraud detection model in production and it's constantly tagging people to have a fraud transaction at all times, then you know your model has drifted. You know that your model is not accurate anymore. And what does that mean? You need to retrain your model again. Now imagine if you just let your model sit there for a week, 2 weeks, 3 weeks without evaluating it at any point, then that means that for that 2-3 week process, 2-3 week time frame, you have this model constantly giving out the wrong predictions, which is detrimental, right? Because essentially, let's look at a fraud detection system, you actually have a lawsuit in place if you've detected fraud. You don't want to constantly be in a lawsuit situation if it's not needed, right? So that's where the risk comes into play. So you need to constantly evaluate this model to understand that if it is getting wrong more often than usual, then you need to retrain and do this process again and put the right model in the right place. So that's model deployment. Then you have your prediction services and your predictions. So now your prediction service and your predictions is essentially just exposing your endpoint. So to put it into software engineering concepts, you just basically have an API that has been exposed, and that API is essentially what is called on a regular basis to get a prediction. So I don't know if I'll be able to get to my actual demo at this rate. But if I don't, then essentially how it works is in SageMaker, you would actually train a model. You would have a model then exposed in an endpoint. This endpoint is then targeted by API gateway or any other service that you're comfortable with to target your API out. And then the person on the other end who needs to utilize this API will get a response from the API, depending on if it's a batch-based or if it's a single-use situation. Does that make sense? Any questions so far? People are quiet. I've also been jumping in and out.
We do have a few questions, but I think we can leave them until the end.
Okay, cool. Let me get through the slides and then we can take questions. Cool. So then another important part is your logging and monitoring. And you can see here, we've got logging and monitoring. And then after your logging and monitoring, we go into retraining. And we go back into data collection. Why is that? So that's essentially the scenario I told you, where if you have a drift in your model and your monitoring solution has picked up on that drift, then you need to retrain your model again from scratch, meaning you need to re-evaluate your data set, you need to recollect everything, you need to clean your data again, you need to ensure that your model is up to scratch again. So that's why your logging and monitoring is super important, because that monitoring is essentially the alert that's going to actually tell you whether you need to redo the entire process or not. If that isn't in place, then you just have a stale model sitting and doing nothing. And that's useless. That is useless in a production environment. So that's why it's essential to have this entire process ready. Cool. I'm just going to quickly go. I'm not going to go through this because it's the same thing, but it's basically everything I was just explained. And then case studies. I'm going to quickly go through the financial case study just to give you an overall architecture. At the very least, I can give you an architecture. So what you see here is a lie. What you see here is a lie, because this is not as simple as it is. And as I've mentioned, that you would use API gateway to expose your endpoint. You would collect your data into buckets. You would train your model, etc. But a very important component out of here is you don't have your CloudWatch, you don't have your CloudTrails, you don't have any of those monitoring elements that is absolutely essential to be able to pick up on drifts. And another important component is your networking aspect, because you don't always, you would fix it in your API gateway side of things, because you don't want to, let's say you have a fraud, I keep referring to fraud detection, but let's say you have a fraud detection model. You don't want everyone to have access to that, because if they do have access to that, then they could reverse engineer that and know when something is tagged as fraud. Now, you can imagine that in the hands of some wrong person, that is very valuable information. They can utilize that system to be able to understand how to find the loophole. So that's where security and networking is absolutely essential, because you don't want this to get into the wrong hands. You can always reverse engineer it. So make sure that only the right people have access to that. What you can see, so essentially what this is only showing you is how the cycle of your data looks like. So let's get through it, right? This is taking your API gateway data coming in. You have a Lambda that would potentially be tagging it. Then you have it going through a Kinesis Firehose, which is like your streaming infrastructure. Then you have this being firehosed into an S3 bucket, and then that is displayed into an analytics tool called QuickSight. In my opinion, this doesn't always necessarily work, but depending on your use case, it can work, for example, in a situation where you don't need to constantly update your QuickSight dashboard and you don't need to have analytics almost immediately, then in that case it works. But if you need a real-time situation, this doesn't always work. Then the second instance you have here is that same S3 bucket is potentially utilized in your model and your data training element. So what happens is you actually go about retraining your XGBoost model using that data. And you have, in this particular instance, we have two models that have been deployed. You have your XGBoost and you have your random cut forest. So you have your fraud detection model, which sits in your XGBoost, which is trained off this information that is being passed down. You have your anomaly detection, which is also being trained on the same sort of data set. And another important component that hasn't been catered for here and isn't being shown in this is your data versioning and your model versioning. Now, the reason why these two concepts are very important is because, firstly, with your data versioning, you need to understand what time frames you're looking at, right? Because different models, models are dependent on your data. So if you're modeling your data to an older data set, you need to be aware of it. If you aren't aware of it, then you're not going to have the most ideal model that is being deployed. So you need to make sure that your data is versioned in your S3 buckets. And I mean, this is where I like AWS, because in your buckets itself, you can actually, literally, there's a little switch that says version, and it versions your data for you. So it makes it very ideal to keep track of what versions of data you're looking at when training your models. In SageMaker as well, there is the concept of experiments, which helps you to also version your models helps you version your models. I don't know what I just said. But yeah, in SageMaker experiments, you can also do that there. So essentially what that helps you to do is, if you have a model version, you could tie it back to a data version in your S3 bucket. And where this becomes key is if you need to debug that at a later stage, you can always just go back to your logs. You can see which version of your model was trained with which data set, and you can understand why your model isn't reacting the way you want to react. And that's why it's important to have these concepts in place, because there is an aftermath of all of this. Then after that, yeah, that's quick. In a quick nutshell, this is where it is. So the reason why I say this is a lie, no CloudWatch, no CloudTrail, versioning, none of that stuff has been incorporated into here. And once again, no ML ops in here. So no CI/CD pipeline has been shown in this particular instance. So we have a little block that says SageMaker, random cut forest, and XGBoost, but that is literally a small component of this entire lifecycle. Now, let me show you something more realistic, right? This is something that's more realistic. And this still doesn't encapsulate everything. And so in this particular instance, I've actually had to deploy this at a client before. And this was actually in the floor. So initially, I started off building a SageMaker model, a custom SageMaker model, a custom machine learning model in SageMaker. And then AWS's Forecast came out. And I actually used it and worked pretty well in this particular instance. So what happens is you have your time series data that comes in your in a CSV or in your Parquet format, whatever format that is necessary. You can get it into that format, and then after that you put that into your training. Oh, okay, that's not for me. So once you've done that, you can put that into your training bucket. That training bucket then goes through your step functions workflow. So now the concept of step functions is purely just a bunch of lambdas that have been set up in a specific workflow in order for you to actually get the right sequencing of your data. Because sometimes you find that you need to first prep your data first. Actually, most of the time you need to prep your data first and then train your model and then do evaluation, right? Sometimes you would find that you need to prep your data, you need to combine data, you need to train a subset of your model, and then you need to retrain that subset of the model on a different data set. So this is essentially where the step functions workflow can be beneficial. There are other ways of doing it. Another way is if you're in the Kubernetes environment, you can also do it with Kubeflow. So that's another way of doing it. You can do it in Azure. I can't remember the Azure one, but there's quite a few ways you can actually create these workflows. Another one that I've used recently is with Airflow. You can also do something similar where you can actually set out these sequences in order to cater for your modeling needs. Then from there on, and the reason why this is a bit more realistic is because you have your CloudWatch metrics in place, you have your SNS, which is absolutely essential, especially when you're trying to detect a drift. You would need to have your SNS in place. You need to have your history. You need your history. Don't forget your history. You need to have a history in place so that if something does go wrong, you know where it comes from. Then you have your forecasting model. So Amazon Forecast is basically AWS has actually created a good working model around forecasting and predictive analytics, right? And essentially, they've got their top PhD guys having worked on the algorithm to ensure that it's perfected to a certain point. Personal opinion, it needs to be worked for a specific scenario. So if your scenario does actually fit the forecasting model, then yes. If not, build your own. I tend to build my own most of the time because I'm picky like that. But if you have a forecasting situation, don't try and rebuild it from scratch. You're wasting time. Use the actual services that are out there. And then once again, you want to be able to display this on an analytics dashboard. That's when you would put this into a quick site bucket, and then in Athena queries if you want to actually subset your data and only show certain parts of the data, and then boom. That's essentially it. And one last thing before I leave, before we take questions. So just to give you an understanding of how the pipeline actually works is you have, and I think I mentioned to you, the Glue ETL jobs. So this JSON, Dynamo, RDS, Oracle DB, all of this can be fed into a Glue ETL job or into several Glue ETL jobs in conjunction with a workflow. And essentially that is your cleaning process. That is your data cleaning process. And essentially once your data has been cleaned, it needs to be put into an S3 bucket or into any other kind of database that you want. From there, those are the assets, and those are the pieces of data that you'll be using to train your model in the long run. But it's shown as a small little component, but this part here between the Glue ETL job and the rest of the database, that's where majority of the work sits. And this is essentially where you would have Spark code, Scala code, all the different types of data cleaning codes that you would actually combine together in order to have one final asset registry of your data. And then once you have that, you have the rest of it. So what I've mentioned with the CI/CD, being able to test, deploy, validate, all of that fits in this and then goes into this. And then from here, you would create your training job, you would create your model deployment eventually, you have your approver, and you find and deploy to prod, and then it goes into your final step. And if you can see, this is actually very similar to like our normal software engineering pipeline, right? It's no different. I mean, there's just a few, like we just have SageMaker model deployment and training jobs, but it's essentially the same CI/CD. And no one really speaks about it because we speak in machine learning and they forget about the rest of the stuff. So yeah, that's my story. I think we can take questions because I've gone over time.
Okay. I'm also try to enable your video again. Let's see if it works. Your audio has been holding up and the slides as well.
I'm trying. Okay, there's my face.
You can see. Okay. Yeah. Thanks for a very insightful presentation. We've got lots of questions. I'm very sad that we didn't get you the demo, but maybe we can schedule a second session of like a follow-up or something, and then we can go into a bit of demo.
I think we need to do that, Rian. I think we would need to do that. We can actually just set up one just for a demo at this point.
Okay, cool.
Cool. Let's go to the questions.
Okay, so guys, you can just fill in that survey if you want to take part in our lucky draw at the end. Otherwise, it's fine. So I'm gonna start with the questions. Do you guys? I'm gonna I noted them down. So Mongi, I don't know. I'm gonna definitely butcher everyone's names. So please don't be offended. But Mongi, do you want to ask your question, or can I ask it for you? Okay, so Mongi asked, what are the tech platforms that sit on every process in the ML lifecycle? I think this is a very broad question. I'm not exactly sure what he means.
Yeah. So essentially, what from my understanding of around what I think that question means is, let me just go to that. So you can see in this diagram here, each of the ML lifecycle, we say data cleaning, all that stuff. it actually fits under. So for example, when I mentioned the versioning element of things, that would be these tech stacks that you see on the top left-hand corner. For your data pre-processing, you'd have, so there's quite a few elements. And I can always share this slide deck with everyone, and then you can see what exactly sits where. I don't think this actually even reflects everything that's out there at this point. There's so much. And we can, once again, we can maybe even maybe have a session where we can actually just take the data engineering cleaning phase, and then look at the tech stacks that we can actually look at from AWS perspective. So there's quite a few.
Okay.
Yeah, is there anything in particular that you'd like to know? If Bungi is still there.
I'm just checking for his reply in the chat, but otherwise I think let's move on, and I'll just note it and we can come back to it. So the next question is from Umer. I'm not sure if that's pronounced correct, but he asked, or she asked, why do we really need to visualize data and perform analysis ourselves, keeping in consideration this is an ML cycle?
So, I mean, as much as we say this is an ML cycle, it's still like there's people that are actually deploying this ML lifecycle. It's not an automated process. I don't think we're not at that point where we can actually automate the data visualization and analysis to a system. There are things like AutoML out there that can actually help you to get things done faster, but you still need data scientists, or you still need data analysts that can actually visualize the data and give you insights into the data, because we don't know what we don't know, right? And often you find that a lot of the insights that are being drawn out is intuition. It's actually intuition and it's statistics, and there's quite a few elements you need to consider before you can actually say whether this is correct or incorrect. So you'd still need human beings to validate your data sets for you. You can't remove humans out of the equation. Does that answer the question?
Yes, thank you.
Cool.
Then we have one from Hendrik that asks, are there any rules around data set minimum size?
Yeah. So once again, it really depends on your use case. So for example, if you have a use case that is high risk, similar like what I've mentioned with the aircraft anomaly detection system, you need to have, the rule is actually if you have 5 features, you need to multiply that by 2 to the power of log 10, like that. There was some rule like that, but it's a very like it's a sporadic number, right? You can't say that and say, oh no, my model's going to work perfectly, because there's so many different elements to it. That's just a number. What's more important is to understand whether you have a representative data set or not. So you can have the largest data set in the world, but if it's not representative enough, and if you don't have enough to cover all the features, then the size doesn't really matter. So basically, the answer, the long and short answer to that is, there is no minimum or maximum size. The real rule is to have a data set that doesn't encourage biasing.
Okay.
Does that answer the question?
Makes a lot of sense. Yes, thank you.
Then we have another one from Umer that asks, 85% of the time is spent in cleaning data. Is there any service in AWS or module that is available to help make it faster?
So, I mean, like, even with the AWS services, you have Glue, you have EMR, you have all these services, which is there, and it has helped, trust me, it has helped data scientists, and it has helped machine learning engineers to make things a lot faster. But even still, you do need to have it still does take time. And the reason why it takes time is because we don't know how disparate your data sets are. You might find that your data sets have tons of noise in it. And only once you've identified how much noise is in your data can you actually understand how long it could potentially take. And if you do know where your noise elements are in your data, then it makes it easier to it shortens that time. It really does shorten that time. And if you have trusted data sources, it's even better. But Yeah, so there is services in AWS that makes it faster. And Rian actually mentioned the new one that with Data Brew, which I'm actually super keen to. I'm probably going to play around with it after this, but it makes it easier for you to actually build those ETL pipelines and help you clean your data a lot faster.
Okay, and then I follow up one from from him was that he was asking what kind of results are published to the bottom, to the bottom S3 bucket. So in your first diagram you had the S3 bucket there, and he was just wondering what kind of data is written back to that bucket.
Okay, so this is your results, right? So this is when you have your service has been published, oh sorry, your endpoint has been published, and you want to have predictions coming in. So in this particular instance, it's a fraud detection system. So essentially, it's every single person that has invoked that endpoint will return a result, whether this is actually a fraud system or not. So the results that are, or the information that is published in here through the stream is whether it is a fraud system, fraud transaction or not. Make sense?
Okay. Yes, thanks.
Thank you.
Then the next one is, in practical terms, what does a model look like? Is it a collection of XML, JSON, or CSV files? Or is it just some big binary dump in a platform-specific format? Like Henry goes on and decomposes it. Is it like fairy dust, pixie teeth, or something else?
It's definitely fairy dust, but over and above that, it's actually it's usually like a pixel, not pixel file, it's a pickle file, right? You have you seen a pickle file ever? But essentially, it's literally a set of binary values that has been transferred into a different format. And what it does is it's actually gathered a pattern. It's a formula, right? It's a formula that has been generated to be able to take in an input, put it through a formula, and give you an output. So essentially, it's, in a nutshell, it's a formula. So if I can put it into mathematical terms, remember back in the day when we said for a straight line, y equals to mx plus c? So mx plus c is what your model is, literally. So you actually give it an input and then it gives you an output at the end of the day. So that's essentially what it is.
Okay. That's a
Thanks.
very cool analogy, thanks. Then the next one is from Lishwa. She asked, what credible sources for training data can be recommended if you don't have your own?
Credible source for training data.
I see that Chris mentioned ground truth.
I think it got answered. I know Sainte-Marie mentioned, I use Kaggle a lot. He mentioned Kaggle and Zindi, there's another one. So nothing else over and above these ones. I use Kaggle a lot, so I think I'm fine. Sainte-Marie did kind of answer already.
Okay, cool. All right. Yeah, Kaggle and Zindi do have quite a few data sources, but it really depends on what you're trying to train, right? Like, for example, if you're trying to do something in the healthcare space, you want to look at the WHO. You know, like you want to look at things that are relevant to your use case. If it's in the fraud space, Kaggle is quite good. Kaggle has like a ton of fraud and financial data, right? So it really depends on what your use case is.
Oh, well, while I have you here, Archana, can I ask my second question?
Yes.
Are banks open to building own fraud detection models these days? I remember when I used to work in these spaces, banks would always keep to certain vendor, very well-known vendor supplied apps for fraud detection because of regulation. Are they becoming open to building own models? Yeah.
So that's a very contentious question, but it really comes down to but it's a valid question, right? I think it depending on who you speak to, right, and depending on how you go about actually securing your data, because the beauty about time is that you actually have solutions. Eventually, solutions are developed, and now these days there's things like differential privacy and federated learning, which help you to make your data private. So you can build your own models, but as long as it's private and it's has been secured, it's technically possible. But down to how you actually position yourself to build a model.
Okay, great. Thanks so much.
And then the last question from Johan, who's asking is what's a different ML services available on AWS? Like you mentioned SageMaker now, and we heard about Amazon Forecast.
Yeah. So I mean, just to clarify, SageMaker is actually, it's a platform. It's a platform where you can actually build your own models. They do have their own inbuilt models that are available on ECR and stuff, but you can build models in there, and you can also monitor and train and all that stuff. So it makes it customizable. There's also Comprehend. There is Lix. There is oh gosh, there's so many. Forecast. There is, yeah, there's quite a few. Yes. Chris said something. Didn't you mention mute?
Recognition.
Yes, recognition. That's another one. That's another one. Yeah, so there's quite a few. Those are just the, depending, if you want NLP, there's Comprehend. If you want computer vision, there's recognition. There is, if you want predictive stuff, oh, another one is personalized. That's another one that's also pretty cool. And yeah.
Okay. I think we went through most of the questions. If I missed anyone's question, now is the time to ask. You can unmute yourself. A second or two. Anything else that anybody wants to say? Nothing. So I actually had a few questions as well, but I think we can. Actually, I want to ask my question. I'm very interested in this. So after you trained your model, and you have to actually now use it in the like real world, how do you go about it? Like you showed API gateway, or actually like this picture, it hits this Amazon SageMaker, but what is Amazon SageMaker there? Is it an actual server that sits there with this model in memory, and then you hit it, and it then takes your input through this formula and gives you an answer, and then it returns? Does it return within like 30 seconds, or I guess you can't have this serverless, can you?
You can actually, you can have it serverless. So essentially what you would do if you want to make it serverless is you would actually, okay, now it depends on the way you're referring to serverless, but if you want to actually, you can have a Lambda that actually publishes your API. So every time you want to invoke your Lambda server, every time you want to invoke the service, you hit a Lambda for it. And that's essentially it. But essentially it's just a container, Rian. It's literally a container that captures the pickle file and has just been published into an endpoint. That's all it is. It's very similar to how an API works. It is an API.
Okay,
it's
but
basically an API. When you invoke the API, yeah.
But you can't load that pickle file with like inside your Lambda function. It's too big, or it doesn't load in memory,
No.
right? You have to either a server that that sits there,
So
that's already warm and has that model ready for you.
Yes, yes. You can't load that pickle file in your Lambda function, no.
Okay.
You can't do that. You need to actually expose it in a separate endpoint, and then maybe you can call it in a Lambda function.
Okay.
But essentially what happens, like once you've actually called that specific endpoint, you get a response. And that's essentially what the bottom half of this diagram is. You get a response, and that response is either true or false, depending on what you're trying to predict.